Welcome to the part 2 of the sample application. Now it's time to create the Cloud.toml as we did in other samples. As we did earlier, we'll be providing the repository, the Docker Hub username, the container name, and the tag. Let's move on to configurables. You can load up values that changes based on the environment easily using configurables. In this section, we are going to see how we can pass configurable values to Kubernetes. First of all, we need to decide if the value we are passing is sensitive or not. If you have both sensitive and non-sensitive data, it's better to split them into multiple toml files, as Kubernetes treats them separately. Just for the demo purposes, we are going to use host, port, and database name fields in the configs.toml file, assuming they are not sensitive, while we store the rest, the username and the password, in secrets.toml file. Let's get started. Please note that the key of the toml should be same as the variable in the bell file. We will explain how we got this value for the host in the later part of this video. The port is the default one. And the database name as well. Great. Next, we are going to mark these newly created files as configs and secrets in the cloud.toml file so that the compiler will include these in the generated artifacts. Great. Now on to resource limits and autoscaling. Setting these limits allows Kubernetes to efficiently allocate resource for your application and autoscale in a very smooth way. Let's see how we can do this. You can simply specify the minimum CPU, memory, and maximum CPU and maximum memory using these fields. Alright. And then you can set autoscaling configurations to specify the number of replicas you need to keep alive, average CPU and memory percentages to trigger the autoscaling, and such things. We will always have at least 2 replicas running. It will scale up to 5. Great. Now on to health checks. Long story short, Kubernetes determines that our application is healthy and running by calling these resources. Liveness and readiness health checks are supported by Code to Cloud. A liveness probe is in place to check if your application is still running and responding to user requests. If this probe fails, Kubernetes will automatically restart your application. A readiness probe checks if your application is ready to receive traffic. If this probe fails, Kubernetes will stop sending traffic to your application until this probe passes. Let's introduce the health check endpoints. Just like any other resource function, we can add these things as well. Call them liveness. We're going to simply return an HTTP OK if this endpoint was called. For the readiness probe, we want to make it a little bit more complicated by making a simple SQL query so that we know the database also is running properly. You can use the database client. We will simply do a select count query. Okay, we need to handle the error. In case of error, we can check it so that it will return a 500. We are not interested about the response as long as it's working. We are okay. Okay. The code is done. Now we can add these probes into the Cloud.toml so that it will generate the Kubernetes artifacts which we need. We just have to give the port and the path for the resource functions. Okay, we are done configuring the deployment. In the next video, we will build the project generate the artifacts, and invoke the application. See you then.